Okay, now we're going to a lesson on dehydration synthesis reactions of proteins. And we know that the building blocks for proteins is amino acids. So the building blocks of proteins are amino acids. So let us begin by constructing the general structure for an amino acid. Well, if you remember, the general structure for an amino acid always has 4 things off of a central carbon. So off of the central carbon, you will always have 4 things. The first thing that you'll have that makes this molecule acidic is a carboxyl group. If you remember your functional groups, so we have a carboxyl group. We'll have an R group. The R group is what determines or makes each individual amino acid different. It could be something as simple as a hydrogen in this position, or it could be something like a CH3 group in this position, but it varies from amino acid to amino acid. But the R group is what's gonna, so that's a side chain that's gonna make it a specific amino acid. Then you're going to have an amino group. And then you're going to have a hydrogen. So this is the basic construction of an amino acid. So we want to first build a dipeptide. Because of space issues, we probably will not do a polypeptide because my screen is so small. Alright, so let's go ahead and begin. Okay, I think, alright, we'll put our amino group out first, move to our central carbon. On top of the central carbon, we want to add a hydrogen. Below it, we want to add that R group. And then we want to end with our carboxyl group. So this is our first amino acid. So we're building proteins, or we're building, remember, proteins also can be or act as enzymes, or they can act as hormones. So if they're protein in nature, so that's what we're building, some type of protein macromolecule. Okay, so we go to our next amino group, followed by our central carbon. Off of the central carbon, we have a hydrogen, we have an R group, and we have a carboxyl group. Same reaction that we used before. We'll follow this by a dehydration synthesis reaction. And I've already run out of room because I write big. So dehydration synthesis reaction. And we don't do any changes to the end of the molecule. So if you look out here, the reaction is taking place where? In here. Because it says we have to do what? We have to take away a hydroxyl group, and we have to take away a hydrogen. So this is where the reaction is taking place. Okay? So one of the things, I'll probably come back and label some things, and I should have labeled it on that previous screen. But anyway, so we're going to start here. So we've got our amino end that has not been tampered with. We come to our central carbon. And off of that central carbon, we have a hydrogen, and we have an R group. And then we come to the remainder of the carboxyl group, because remember, we removed a hydroxyl group from the carboxyl group. So here's the remainder of that carboxyl group. And notice, we've taken away the hydrogen off of the amino group, so we're going to go straight over to that. Our covalent bond is going to be straight over to that nitrogen. One of the things that you'll see is that a lot of times that they'll flip this down because of steric hindrances. So the nitrogen will be down there, and they'll actually even flip that next R group up to the top, and you can draw them plain, just straight across. It doesn't bother me not one bit. And then a whole carboxyl group, the C double bonded to the O, and then an OH. Ran out of room again. We'll try to draw it again, but anyway, and don't forget, we need to add water out here. So let's do this again on the next slide. And draw smaller. Alright, so here we go again. We have a central carbon. And I am too close that time. Eraser. Oh, there it is. Sorry about that. Alright, so let's go back. Alright, so we have a central carbon, and off of that central carbon, we have this amino group. Have mercy. Small again. And off of this, we have a hydrogen. We have an R group. So we're drawing an amino acid one more time. And then we end up with our carboxyl group. Okay? And then we want to add another one. So we have a central carbon. Off of the central carbon, we have amino group. We have a hydrogen. We have an R group. And we have a carboxyl group. Remember again, carboxyl groups makes things acidic. Okay, again we're doing a dipeptide. So this is amino acid number 1, amino acid number 2. We're going to take away hydroxyl group. We're going to take away a hydrogen. Perform a dehydration synthesis reaction. Okay, and remember we haven't touched anything out there on the far left, so that remains the same. So that whole amino group coming into the central carbon, where we have a hydrogen and we have an R group. And then we have a carboxyl group. Okay, but we've taken away the hydroxyl group, so that takes us right over to the nitrogen, which has a hydrogen off of it. And then we move back into the central carbon, which has a hydrogen and an R group. And then from there we go to our carboxyl group, and then we want to add in water. Okay, because we took away water right here, remember. So what is joining these two molecules together is what's called a peptide bond. So we have a peptide bond. Peptide bonds are the characteristic bonds of proteins. Remember, a glycosidic bond was a characteristic bond of carbohydrate molecules. And just like the carbohydrate molecule review that we did, it says, can we break these apart? Yes, we can. By doing what? Performing a hydrolysis reaction. Okay? So on this side, we have amino acid 1, amino acid number 2. On this side, what do we have? A dipeptide. If you're going to create a polypeptide, then you want to use more than 2 of the amino acids in order to create that, which would mean that you're going to have more than 1 water molecule. Okay? So this concludes our lesson, or small review on creating a dipeptide for your dehydration synthesis review.